This video is going to go over another strategy for the SOL, which is going to talk about the key formulas that you should know that are not on the formula sheet. So we're going to talk about all of these, and we're going to break them up into certain sections. We're going to go through the problems from the 2014 and 2015 released SOLs to show how we need these formulas to do the problems. So the first one is distance, midpoint, and slope. So this is the bottom of the first page of your formula sheet. The reason why I showed this is because I think this is the ideal place to put distance, midpoint, and slope. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We also have the midpoint formula, which is just the average of x's, so we add the x's up and divide by 2, and we add the y's up and divide by 2. And lastly, we have the slope formula, which is rise over run. So remember, the rise is y2 minus y1. The run is x2 minus x1. So whenever we know these formulas, it's really going to help us in solving these problems. So if we keep going here, again, the one strategy that we had in reading the questions, what is the length of segment ST? So length, you should be thinking distance. Those two things have the same meaning in this case. So we just have x1, y1, and x2, y2. We plug it into our formula and we solve it. So the distance formula can help you there. If we go to this one, we have our question plot, our question or command word plot a point other than P with integral coordinates that is on a line parallel to T and passes through point P. Well, we would need to use the slope formula here. We would have to use slope because the slopes of parallel lines are the same. So that's just y2 minus y1 over x2 minus x1. So once we would find the slope, we could just simply count how many points away, how far up and how far to the left or right we would go and plot that point. Again, what is the slope of PT? Really simple here is just rise over run. So again, another slope problem. This one should be one of the easiest problems on the SOL. This one here, you might not suspect it to be any of these. It says which point lies on circle O. But if we remember what a circle is, so I have a circle and I have the center to the point on it is the radius. So you can use the distance formula here. You can try this and this, for example. That would be x1, y1, and this point would be x2, y2. This is not the advisable way to do this. It'd be much easier to use the equation of a circle, which is given to you on your formula sheet. But this is another instance where we could use the distance formula here to solve this. So now we're on to the 2015 released SOL with this one. Which ratio represents the slope of a line parallel? So again, parallel lines have the same slope, y2 minus y1 over x2 minus x1. We're going to use these 2 points, so that could be x1, y1, and this could be x2, y2. So we just plug it into the formula, and we have it. So the next formula, you might say, well, isn't this already on here? It's SOHCAHTOA, or trigonometry. So we have this right here to kind of help us out, but it's not written as most geometry teachers write it, including myself. So what I recommend you write is, right here is SOHCAHTOA. I like writing it right here because all of these formulas have to deal with the right triangles. So if you ever see a right triangle problem and you're a little bit unsure of what to do, you can turn your formula sheet over to the back and you have the formulas right there. So we talked about the front of the sheet, putting distance, midpoint, and slope. And on the back, we have our right triangles and our circles formulas. So right here we have a SOHCAHTOA problem. Here's our angle. There's our opposite, adjacent, hypotenuse. So we would use SOHCAHTOA. Remember, whenever we have a right angle, we're going to be using either the Pythagorean theorem or SOHCAHTOA for right triangles. If we have or need an angle, we have 20, we're going to use SOHCAHTOA. We don't have, sorry, we do have the adjacent. The adjacent is x. We do not have the opposite in this case, so that would mean we would have to use cosine. So without doing the whole entire problem, I'll just start it. The cosine of 20 degrees is equal to adjacent x over the hypotenuse, 80. So that's an instance where we'd use SOHCAHTOA. Comes up quite a bit. Here's another one where we have an angle, and it's a right triangle, so we know we'd use SOHCAHTOA. Another one, right angle. This time we need an angle. So maybe we didn't cover this one enough in class, so let's actually solve this one. The hypotenuse is right here, the opposite is here, and the adjacent is here. So once we label our triangle, we see that we have O and A. We do not have a hypotenuse, so we have SOHCAHTOA. We don't have the hypotenuse, so that means we have to use tangent. So the tan of x is going to be equal to opposite, which is 8, over 7.8. To solve this, we need to use tan -1. Whenever x is attached to sine, cosine, or tangent, we're going to use sine -1, cosine -1, or tan -1. So now I'm ready to just enter that into my calculator. I have to make sure my calculator is on the correct mode. So I hit mode and I see that it is on degree. So I hit second tangent. It's going to be 8 divided by 7.8. So we get our answer of 45.72, which is just C. Again, right angle, have or need an angle, we use SOHCAHTOA. One formula that I think is very important that's not on here, probably the most important one, is the interior and exterior angles. These are formulas that are pretty easy to remember, but maybe you're struggling to remember them. A great place to write them would be right underneath the circles. There's a little gap right there. So the way that I had it was I taught my students to write a chart, the sum or each on a regular polygon. And we had a little chart, and we had interior and exterior angles. So the sum of interior was n-2 times 180. The sum of the exterior was 360, and then when we needed to find 1 on a regular polygon, we would just divide it by the number of sides. So remember, n stood for the number of sides. So n was the number of sides. Hopefully that's something you already know, but again, it's something that's not given to you on the formula sheet, and you really need to know it. So to solve this one here, what is the measure of angle JKL? Well, what we should see is JKL is this angle plus this angle. Those are two exterior angles. They're each, so these are both regular polygons. We're told it's a regular nonagon. That's 9 sides. So it's going to be 360 divided by n is the formula we're going to use. So it's going to be 360 divided by 9 plus 360 divided by 3. That's from the triangle. That's from the triangle. That's where I'm getting the 3. Remember, n stands for the number of sides. So we get 40 plus 120 gets us 160. So that's how we would solve that problem. This one here says, what is the measure of angle U? to solve this, we need to figure out what the sum of angles is. So that would be n minus 2 times 180. This polygon has 6 sides, so it's 6 minus 2 times 180, which is 720. So then you just add these up and set them equal. So we have 2x plus these angles here, when I add them up, add up to 480 equals 720. So x is equal to u. That's how we would solve this problem. The purpose of this isn't to solve it, but to show you how important the formulas are to solve them. This one here, again, we have another exterior angle. So we can solve this part by doing 360 divided by n. Since it's an octagon, it's 360 divided by 8. So we know that this part of the angle is 45 degrees. Once again, that's not the answer. It's part of the answer that you need to solve it. Again, these formulas are very important. This one here says it directly. What is the sum of the measures of the interior angles of this polygon? N minus 2 times 180. When I go back to my chart, I have interior and sum. So that's where I'm getting that formula from. Read the problems, be familiar with the chart, and you'll be able to solve these problems pretty easily. So it says it's a polygon with n is equal to 5, a, b, c, and d. 5 minus 2 times 180, and that'll get us 540. Another formula that comes up pretty frequently is arc length and sector area. To do this, we have to realize that the arc length is part of circumference, and sector area, it's part of the area. So what we do is we take our circumference and our area formulas and we just multiply it by the central angle over 360. And you do the same thing for the area, the central angle over 360. So we'll take a look at several problems that have been on the last 2 released SOLs. Which is the closest to the length of the railing needed for the curved section of the balcony? So what they're doing here is they're not stating it explicitly, the curved section of the balcony. This is arc length. So we find circumference, that's 2 pi r, and the arc length is going to be 2 pi r times the central angle over 360. So the radius here is 40 and the central angle is 70. So that's as far as I'll take you on that problem. Which is the closest to the area? So we see the word area. We also see it shaded in. When it's shaded in or we see area, we know we're going to use sector area. So it's pi r squared over times central angle over 360. So I'll erase this to show you that the angle is 130. Just plug in our values. Here's another one. Which is the closest to the area? So we should see that this is part of an entire circle. So which is the closest to the area? Pi r squared times 80, that's our central angle, over 360. This one has a lot more reading, and it's one of the more difficult ones. So it says, which measure is the closest to the length of the arc? So that's what we're looking for. The minute hand travels during this 18-minute period. So we're looking for this length right here. The central angle is 108. The reason why I say it's a little tricky is because you might not know what the radius is. We have to keep a reading. It says the minute hand on the clock is 10 centimeters long, so the minute hand's 10. So it's going to be pi r squared times 108 over 360. And remember, r is 10. So we have other important circle formulas that aren't on here. Usually there's 1 or 2 questions dedicated to the SOL where we have to know these formulas. So they're kind of a pain to memorize. There aren't any really good ways to memorize them. A good place to put these, and these are a little bit larger to see, would be at the bottom of the second page. A good way to remember the ones on the left, I'm not sure if you can read this that well, but it's on the circle, inside a circle, and outside the circle. So I will hope to upload a page that will have these formulas bigger on a Word document. So the ones that we have to solve, so this one says, what is the value of y? There's a whole lot of things we can do here. Probably the easiest thing we can do is if we trace y, I see that that's an inscribed angle, and this is just going to be double whatever y is. So this is a multi-step problem. We first need to solve the angles in this one. So this is a vertical angle, so that's why that's 92. And then I can find the third angle by taking 180 minus 92 minus 50. So let me get my calculator out to just double check that. 180 minus 92 minus 50. We get 38. So if that's 38 degrees, we spread this line out and we see that this is going to be double 38. So double 38 is 76. And then if we go backwards to where y is, we see that y has to be half of 76, which is 38. So that one requires some thinking, some multiple steps, but ultimately what we did was we did the formula on the circle. We used this formula here, the inscribed angle formula. This one here is a problem with segments. So I look at that, it's going to be 5 times x. So I multiply the two sides, it's going to be equal to 2 times 3x minus 2. So we just have to do some pretty simple algebra. 6x minus 4 is equal to 5x. We subtract 6x. Negative x is equal to negative 4. Divide by negative 1, we get x is equal to 4. So it says, what is the length of kz? So we might be wondering why 4 is not there. It's because it shouldn't be there. Kz is equal to 2 plus 3x minus 2. So kz is equal to 2 times 3 times 4 minus 2. I'm doing substituting the 4 in for x. Whenever we do this, we get 12. And that looks like that's it for the important formulas not on the SOL formula sheet. So we had quite a few different things. Again, these are them right here. And I recommend that if you don't want to write those down on the formula sheet, that at the very least you know them. If you're one of those people that memorizes things and forgets them very easily, they're very good to memorize right before the SOL. Put them on the pieces or the parts of the paper or the formula sheet that I recommended, and it should help you a lot.